So, good morning, everyone. Uh, Today, we are going to see a topic about linear regression. So, before getting into linear regression, first we should understand what is machine learning and what are the types of machine learning algorithms. So, these are the contents today we are going to see. First, we will see what is machine learning and machine learning algorithms. After this, we will see about linear regressions and what are the types of linear regressions like simple linear regression and multiple linear regression. Then after this, we will see applications of linear regressions. And finally, we are going to see an example project of house price prediction project. And I will explain this in Jupyter Notebook. So these are the contents we are going to see today. Now first, what is machine learning? So machine learning is a subset of artificial intelligence. So first we have to see what is artificial intelligence. So artificial intelligence is the science of training machines to perform human tasks. So this is called it's if any human tasks like thinking or it's like mimicking the human brain, like thinking and creating a task, creating a new thoughts, like whatever the task human performs from thinking to action, the same it mimics is called the artificial intelligence. So this is an artificial intelligence, and when it comes to machine learning is a subset of artificial intelligence that instructs a machine how to learn. So, it like instructing a machine how to learn from the given data, from the available data. And machine learning is a branch of artificial intelligence that focuses on the development of algorithms and statistical models that can learn from data and make predictions on data. So it will learn itself from the available data and make predictions on the data So this is a machine learning, and the machine learning process incorporates various machine learning algorithms that allow a system to identify new patterns, new insights, and to make decisions without any human involvement. So that's the main purpose of machine learning and artificial intelligence. So it's one of the subset of AI. Then if we go with the machine learning algorithms, machine learning algorithm is a set of rules or processes used by an AI system to conduct task. The task means most of the tasks to discover new data insights and patterns, or to predict output values from the given set of input variables. So it's like a set of rules and processes used by an AI system to conduct any operations, to conduct any task, like that. So it's basically deals with the data. If you give certain input data, it will discover a new data insights and patterns to predict the output values. Then these algorithms enables machine learning to learn. So if you build any algorithms like machine learning algorithm, that will enable the machine learning to learn itself from the data. So these are the machine learning. This is a machine learning algorithms definition. Then there are different types of machine learning algorithms. So in the machine learning algorithm types, there are four types of machine learning algorithms. The first one is supervised learning. Then second one is unsupervised learning. Uh, and the third one is semi-supervised machine learning algorithm, and the fourth one is reinforcement machine learning algorithm. So these are the four types of machine learning algorithms. Now we will see what is supervised and unsupervised. Then we'll go with the next machine learning algorithms. So generally supervised versus unsupervised machine learning algorithm. When it comes to supervised learning model, the algorithms learn from the labeled data. So in that we'll use the labeled data. So we give input and the corresponding correct output to the algorithm. The algorithm then trains on the given data set to predict the output from the unlabeled data. Here we have example of supervised machine learning algorithms called decision tree, SVM, k nearest neighbor, and linear regression. So these are the examples of supervised learning algorithms. Then when it comes to unsupervised learning model, the algorithm trains on unlabeled data with no knowledge of the output. So when it comes to unsupervised, it's an unlabeled data. The algorithm trains on unlabeled data. If it is a supervised, the algorithm trains on the labeled data. The example of unsupervised learning machine learning algorithms are k-means, LDA, PCA, and the mean shift. So these are some of the examples of unsupervised machine learning algorithms. Then when it comes to semi-supervised and reinforcement, in semi-supervised learning model, the algorithm uses a hybrid approach that requires using labeled data and unlabeled data. So using labeled data and unlabeled data. So when it comes to supervised, it uses only labeled data. When it comes to unsupervised, it uses unlabeled data. When it comes to semi-supervised, it uses both the labeled data and unlabeled data for training. So it trains using the labeled data and then gets the additional information to increases its understanding and performance using unlabeled data. So it's like combining of both supervised and unsupervised machine learning algorithms. So that's called as a semi-supervised machine learning algorithm. Uh, then the last one in reinforcement learning model, the algorithm directly interacts with the environment and it given a two types of actions like reward and penalty. So it will give a reward. It will given a reward for correct responses for correct response, and it will give a penalty for wrong decisions. So the algorithm learns from its mistakes to improve performance. So it's like both reward and penalty as per the decisions. So this is called reinforcement machine learning algorithm. Uh, Now next we'll see about what are the most popular machine learning algorithms. The most popular machine learning algorithms are like linear regression, that we are going to see today. What is linear regression and in depth of how we are going to implement this linear regression model. Then there are logistic regressions, decision trees, SVM algorithm, Naive Bayes algorithms, KNN algorithm. K means random forest algorithm, dimensionally reduction algorithms, then gradient boosting algorithms and ADA boosting algorithms. So these are the most popular using machine learning algorithms. Then today our topics is linear regression. So we'll see about linear regression and its types. So when it comes to regression, the linear regression analysis is one type of machine learning algorithm. It's used to predict the value of a variable. Based on the value of another variable. So it's like finding one variable based on the value of another variable. So the variable you want to predict is called a dependent variable. Uh, is called a dependent variable, and the variable you are using to predict the other variable's value is called an independent variable. Uh, so there are two types of variables. One is dependent and independent. Uh, independent variable will be in x-axis and dependent variable will be in the y-axis. So you are going to find the dependent variable. Okay, so there are two main types of linear regression. One is simple linear regression and multiple linear regressions. So when it comes to simple linear regression, this is the simplest form of linear regression, and it involves only one independent variable and one dependent variable. So not more than that, only these two variables, and the equation for simple linear equation is y equal to mx plus b. So this is a very important equation for simple linear regression, and this equation is very useful when you're solving any problems or when you are dealing with the Jupyter notebook, like house price detection project. So here the y is the dependent variable, y is the dependent variable, and x is the independent variable, and m is the slope. M is the slope and b is the intercept, and b is the intercept. So this is the simple equation of simple linear regression. Then we'll see about the multiple linear regression. In the multiple linear regression, this involves more than one independent variable and one dependent variable and one dependent variable. So this is the definitions of multiple linear regression. The equation for multiple linear regression is y equal to m1 x1 plus m2 x2 plus m3 x3 plus b. So here I have considered only three independent variables, but we can also take as number as possible, like it goes to like m4 x4 m5 x5 to up to mn xn. So it goes on like up to m1 xn. So I just taken only the three independent variables. Okay, so m4 x4 to it goes to like m1 xn. So this is the important equation for solving any problems. Y equal to m1 x1 plus m2 x2 plus m3 x3 plus b. Yes, same, the y is the dependent variable, then x1 x2 x3 are the independent variable, then m1 m2 m3 are the slopes, then b is the intercept. So these two equations are important in solving the problems and for the house price prediction project. Then when it comes to variables, there are different types of data variables. Mostly these two types, one is dependent variables and independent variables. In dependent variables, in simple that the data that can be controlled directly. So if we can control directly, then it's called dependent variables. So other name for dependent variables like outcome variables, target variables, response variables. And the examples for these dependent variables are like income, price of a home, temperature, etc. So these are like outcome that data can be controlled directly. Then when it comes to independent variables, that data cannot be controlled directly. You cannot control the data directly. Other name is, these are called predictor variables. So predictor variables means by using these variables you are going to predict other variables. Then it can be an input variables and explanatory variables features, and examples are like age, day of the week, years. So these are called independent variables. Now when it comes about the linear regression line, so first we will see the relationship here. Yeah, linear line showing the relationship between the dependent and independent variable. Between the dependent and independent variables is called the regression line. So here you will see the graph like a scatter plot graph. Here x-axis and y-axis is there. So x-axis has independent variables and y-axis have dependent variables. So in that there is a one line called a regression line. This is called a line of regression or regression line. And um, the above and below you see the points. These are called the data points, where the data points scatter in the scatter chart. So this is a data point. The blue dots are called data points, and this black line is the line of regression. And basically it shows the relationship between dependent variables and independent variables. And this is a best fit line as a line of regression. And a regression line can show two types of relationship. One is a positive linear line, and one is negative linear line. So in this graph we have seen that the graph is going upwards. So this is a positive linear line. So if any graph shows downwards like this, so this is called a negative linear line. This is called a negative linear line. So this is a positive linear line and this is a negative linear line, and this intercept with this x-axis. So that's the line of regression. Now when it comes to the applications, machine learning uses data to make predictions about future events and outcomes, to make predictions. Then a few of the devices and applications that rely on machine learning are mobile devices. So mobile devices, mostly everyone we are using mobile devices. That mobile devices are rely on machine learning uh, algorithms. It will use to collect the data of uh, whatever you are using. Then self-driving cars is a good example for machine learning algorithms. Then the Google search engine uses machine learning algorithms to get the best to get the best results, to show the best outcome recommended websites. Then Netflix movie recommendations, it uses the machine learning algorithms, and it will decide what streaming movie you have to watch next once you have finished that movie. Then for facial recognitions, we are using machine learning algorithms to detect the facial expressions Then mobiles and mobile check deposits, we use machine learning algorithms. Then the most important is wearable fitness trackers and smartwatches uses machine learning algorithms and collects our um, uh, data of our body temperature, pulse rate, etc. And it also uses it also measures the steps, counting of your walking, calories burning. So this and all uses the machine learning algorithms. Then to identify the most efficient routes for trucks, cars, by using machine learning algorithms, Google Maps. These are the examples of applications of using machine learning algorithms. Then linear regression models may play an important role in shaping the future technology. Definitely, it will make an important role in shaping the future technologies. So these are the applications of machine learning.